An inequality is the comparison of two expressions. And we have multiple signs to go within that we'll talk about in a minute here. But the thing with solutions for inequalities is that they have an infinite number of solutions or a range of solutions, not just a single solution. For an equation, it's just x equals 3 or x equals 12. But for an inequality, it would be something like x is everything greater than 3 or x is everything less than or equal to 12. So there's an infinite number of solutions for inequalities. So that's why we represent them usually with a graph, but we can also represent their solutions with an inequality or an interval. And we're going to look at representing all three types of those solution representations. So there is one thing you guys have to remember when you're solving for an inequality. For the most part, it's exactly the same as solving for an equation, except this rule right here. When you're solving for inequalities, you want to always remember to flip an inequality sign if you multiply or divide by a negative value. So anytime you divide by -6, or if you're multiplying by -2, if you did the operation of multiplying or dividing by a negative, you need to flip the inequality sign, because essentially that negative is telling it the opposite thing, and you need to make your inequality opposite. So a solution is read left to right. So generally I will try to keep the solution so that the x variable is on the left-hand side. And then you would read it as x is less than 8. If you don't keep the variable on the left-hand side, these two things really mean the same. It's just that one is read as x is less than 8, whereas the other one is read as 8 is greater than x, still meaning that x is less than 8. We just read it the opposite way. So both of them are the same solution, just written differently. So I will try to keep my variable on the left because of this little thing over here that I wrote. As long as your variable is on the left-hand side, the inequality always points to the direction you guys should shade. Now when we do compound inequalities, it'll change it up a little bit. But for a single variable regular inequality, as long as that variable stays on the left-hand side, it shows you which way to point. So let's just talk about our different signs. So our four signs are less than or equal to, greater than, and greater than or equal to. So less than would be everything less than and up to that single value, but it's not inclusive. So the less than isn't including the value itself that you found to be the solution boundary point there. Whereas the greater than or equal to and less than or equal to with that little bar underneath there, they do include the values. So when you guys are graphing, less than would be whatever your number value is to the left. And then less than or equal to, since we're including it, we show that we're including the value by filling in the dot. So at that boundary point where your number is, we're just kind of have a solid dot, but it's still everything to the left of your solution number. So then greater than would be that number and everything to the right of it. And then greater than or equal to will be filled, but to the right. So let's talk about interval notation. You guys have sort of done graphing on a number line, but you've never really done much with interval notation. So for interval notation for less than, if it's all the numbers to the left or less than that number, to the left in that forever direction is really negative infinity. So to show that the solution in interval notation, we say every number up to whatever your solution was, but it's coming from negative infinity. So infinities you can never reach or approach, so they'll always have a parenthesis, and if we're not including the number it's also going to be a parentheses. So open dots go with parentheses, whereas like the next one, less than or equal to, still coming from negative infinity, but at that solution we're including it. So we're going to use a bracket, like a square parenthesis almost. So a bracket represents that we're including the value. So then for greater than or equal to, it's going the opposite direction forever in this way, which is positive. So in this case, your solution starts at the number and goes to positive infinity. And then the greater than or equal to still starts at that number, but we're including it, so we're going to do a bracket, still going to positive infinity. So the dot and that line tell you guys if you're using a closed or open dot, and then depending on if it's closed or open determines on whether or not you're including it with the bracket or not including it, which is when you use the round parenthesis.